Welcome to the Tom Nelson podcast. I have Dr. Jerome Corsi here. And Jerome, could you tell us a little bit about yourself to get us started?
Well, sure. I mean, I've been writing since about 2004. I have two number one New York Times bestsellers, The Unfit for Command against John Kerry in 2004. The Swiftboat book was probably my first major book as a popular book. And I wrote Abomination against Barack Obama in 2008. That was the number one New York Times bestseller. I've written three books on energy and the climate. This is my third. And this one I think is probably the most comprehensive of all the books I've written. I've had a very long career, very complex. I was at universities. I have a Ph.D. from Harvard in political science, which goes back to 1972. I had careers in academics, did a lot of federally funded research. And I've just had, a long career in business. I had a long career working in banking and finance for almost 30 years. I still do some in banking and finance. I've never quite given that up. So it's been a very diverse career, and I'm looking forward to what I'm doing now and continuing to do now, which is to really write and to continue doing, producing books and articles and doing podcasts like this. And the climate and this nonsense of climate change and global warming, the bad science, has been one of my passions. I've written a lot about it and intend to write more.
And about how long have you been involved in heavily into the global warming skepticism or digging into that whole controversy?
Well, I've almost from the beginning of the time I started writing publicly. I mean, this has been a subject even when I was a kid. I always had the instinct that the idea that oil came from dinosaurs, which in the 1950s was the vogue. And we had Dino the dinosaur, which I believe was the symbol for Sinclair Oil. And I always thought that was, even as a child, I thought that was ridiculous because organic material doesn't deteriorate into a higher form of energy. I mean, we deteriorate into dust. We're buried because we stink. You don't line a casket and say, Matilda's going to turn into oil. It's never happened and never will happen. And the geologists who think that oil is formed in sedimentary rock really don't have any provable explanation of their theories. You can't replicate them in a laboratory. Whereas we'll get into this more, but the whole idea of abiotic oil, the chemistry of oil is very well understood, and it can be made synthetically, and it's made in the mantle of the earth. And I guess when you say, when did I get into the controversy? I've always been in the controversy because I was arguing with my father over these issues when I was a child. The book, it's been out now for a while. It's the truth about global warming, about energy, global warming and climate change, and the subtitle about all the climate lies, exposing the climate lies in an age of disinformation. That's what the book is about. It's volume one of three books, which I'm writing in a Great Awakening trilogy. I've finished the second volume, which is now going to be in print in 2023. And that's about neo-Marxism, cultural Maoism, and anarchy. And it's about the intellectual evolution of the critical theory that the left is proposing now and how they got there. And it's, we mostly, as conservatives, do not understand the depth of the nature that's gone into the thinking and alternative life views behind post-Marxism or cultural Maoism. And these are really fairly bizarre theories, postmodernism, etc. So that's my second volume. And my third volume, I think, will be on transhumanism, where the globalists think they're going with a Ubermensch superhumans that they're going to want to create in the next generation of their aberrations and godless views of who we are and what we're here about. But at any rate, this book, I think, is, I wrote a book in 2006 with Craig Smith of Swiss America, a gold trading company. We talked about abiotic oil. It was called Black Gold Stranglehold. And then I published a book a few years later about the Nazi synthetic oil, which they were able to create during World War II, the Fischer-Tropsch process. We'll talk about that in a minute.
Okay.
So again, I've had really, this is my third book, and central to this book, it's about, it's one of the later chapters, but it's kind of influences the whole book. It's, I guess, chapter what is it, chapter 9. And the book is almost 400 pages long. It's heavily footnoted, 1,000 footnotes or more. And it's one of my, I consider this to be more of a, major life's work, a major statement on these topics. Because again, I went into the science, chemistry, the physics, as well as the political philosophy. And the book starts out with the philosophic movement that co-opted environmentalism to become really neo-Marxist, anti-capitalist, which is the core of what global warming and climate change is all about. But let's go into abiotic oil. The idea of abiotic oil, again, as I said, is that oil is a natural process. I mean, if you go back into the distinction between organic and inorganic chemistry, which always intrigued me, because there was a presumption that there was carbon-based chemical structures were more somehow living, and other chemistry, which is non-carbon based, was not living. So the hydrocarbon fuels got subcategoried under organic chemistry, which is a presumption, of course, if it's organic, it's alive. Well, I mean, there's no living or dead chemicals. They're just chemicals. They're all the same. They've got atomic structure. They're fairly well understood from an atomic level. We're learning more about, quantum theory and subatomic particles, et cetera. We're getting, that is expanding now, but it's still all just chemicals. And so therefore, the idea that oil is somehow or other a living product or a residue from living creatures is pretty much nonsense, because there's no way that you're going to take the constituent chemicals that go into a human being or a dinosaur or an amoeba or plankton or anything else and have it decompose into oil. And I think the fossil fuel geochemists, who are by and large still the majority in the traditionalists, when they try to explain how they get this kerogen, which is this kind of rock before it's going into oil, it almost sounds like alchemy to me. I mean, you can't produce kerogen in a laboratory. The idea that the sedimentary rock is forming oil because it has detritus of whatever kind it is, and they backed away from dinosaurs because obviously there were not enough dinosaurs to make oil the quantity we have it. And besides that, a fossil is not the animal. The fossil is the usually silica remains of the animal after the animal's long ago gone, but rock structures fill in the structure, and the structure, the skeletal structure of the animal at least is preserved. And in certain cases, they're finding, depending on how the animal died, there may be even tissue and skin. They find this commonly with mammoths in Siberia. But the point is that it's not normal for us to imagine that biological tissue is going to deteriorate into oil. So it goes really back to Medvedev, who is the guy who developed the atomic chart for chemistry that we all learn in the chemistry course. And he, in the 1800s, said that oil was abiotic. It was formed in the mantle of the earth, and it came up through cracks in the earth and pooled in sedimentary rock, which I believe is correct. Now, since the 1800s, a lot of work has been done. The most critical work that was done was the Weimar Republic in Germany. Germany realized at the end of World War I that it had no real oil reserves, a lot of coal. And if you're going to fight World War II, there was an awareness after World War I that World War I hadn't settled anything. The German people certainly felt like they got betrayed. And the armistice came when they felt like they were having advantages in the field. I mean, it was, first of all, an insane war with the fought with machine guns in trenches, was suicidal, and literally millions died in combat, which was pointless, fighting over a few yards of territory that didn't shift in years in any significant way. We never got to Berlin, and the Germans never got to Paris. They're fighting over these marginal areas by Belgium and the outskirts of outskirts of France, etc. So at any rate, the German chemists decided they were going to study oil and figure out how it was created. And they came up with a series of equations. Fischer-Tropsch, Fischer and Tropsch were two of the chemists involved in this. And they basically figured out how oil was synthesized. And it basically comes from taking something that has a carbon structure and something that has a hydrogen structure, and figuring out how in intense pressure and intense heat you can produce hydrocarbon chains. Now, hydrocarbon chains, which are basically structures of carbon and hydrogen, there's many of them, but you'll see them, for instance, benzene is C6H6. Okay, which, so you're basically saying, okay, CO2, carbon dioxide, is one molecule of carbon and two molecules of oxygen. So when you get these carbon chains, benzene is 6 molecules of carbon and 6 molecules of hydrogen.
Atoms, right? Yeah.
Atoms, which are arranged in a lattice structure. So these are the atoms that go into the creation of a molecule, benzene. Okay, it's an atomic structure that determines that it's oil. And there are many different hydrocarbon structures. I mean, I detail a large number of them in the book and show how they are produced, but there are many, many different, what they call straight chain hydrocarbon atomic structures, which are basically different combinations of carbon and hydrogen in different atomic chains linked together, but basically straight chain. They're not very complex. And so what the Germans realized was that if they took coal and put it through a process which essentially made it into a gaseous form in the presence of a catalyst, they were first using iron zinc oxide as a catalyst, that they could, under pressure and heat, produce a catalytic conversion, basically, a chemical process which generated hydrocarbon chains. And the hydrocarbons they were straight chain alkalines, which are saturated hydrocarbons, and they have a very simple formula, CnH2n plus 2. So in other words, it's not a complex chemical process. And anyone who studies hydrocarbon petrochemistry, hydrocarbon chemistry, is going to learn how these chains are composed. But the question is, how are they formed? Now, what the Fischer-Tropsch process showed is you can produce it synthetically. Synthetically, you don't have to, there's no part of the Fischer-Tropsch process that says kill some chickens and throw in parts. You don't need organic material.
But I'm sorry, when the Germans did this, they started with coal, right? Started with coal, and that came from organics originally? Trying to understand this.
Yes, okay, but again, it's the hydrogenation of coal. Coal is itself formed abiotically. Coal is a form basically of metamorphized oil, just like rock is soil, sedimentary soil that under intense pressure and heat changes into metamorphic rock. Okay, which is basically, you can see it when there's folds, synclines, and anticlines, for instance, intense pressure which shapes the sedimentary rock, in that pressure, you get a lot of metamorphic rocks forming.
Okay.
They're hard forms of coal is a hard form of oil. It's not liquid anymore. Okay, but the chemical composition of coal is basically a hydrocarbon composition. And so therefore, again, it's going to be formed by the same chemical processes that would produce oil. If you could do it synthetically, then the next question is looking for where in the earth you could have the processes, the availability of carbon, hydrogen, and oxygen reactions in the Earth's mantle, which I show basically you've got exactly what's needed for the Fischer-Tropsch process, where you've got the carbon, the hydrogen, and the oxygen in there. You can produce iron oxide, which basically becomes the catalyst to combine the various elements of carbon and hydrogen. And the mantle of the Earth, which is a very thick, it's about 1,800 miles thick. It's about 84% of the Earth's volume and 67% of its mass. It's a large body of the Earth's structure. And essentially, when I looked at the structural geography textbooks, and I do that like on page 265 of the book, and I show you how there's a lot of the crust has sedimentary, metamorphic, and igneous rocks. I mean, those are your three categories. Rock is sedimentary, which is like basic soil. You dig it up in the backyard. That's sedimentary rock. Metamorphic, it's hard. So it's hardened by heat, but it will have the same composition chemically as sedimentary rock. And then igneous rock is what comes out of volcanoes. And it's like obsidian and other forms of really hardened material is coming out of the fire producing volcanoes. And so those are your three basic kinds of rock. Mostly these changes involve metamorphic rock, but under intense pressure and heat, metamorphic rock does not become solid. It again becomes more liquefied or gaseous. And thereby it's releasing the chemicals. So in the presence of a catalyst, you can get something that has hydrogen and something that has carbon to bind into hydrocarbon forms. That's basic. I mean, this should be chemistry 101 or at least, the second year when you get into organic chemistry, these concepts should be presented.
And this process is happening right now as we speak, right? Way down in the earth, the new oil is being formed.
Constant. It never stops.
Yeah. And how far down is it happening?
Well, it happens through the mantle. Now, the mantle goes about 1,800 miles down. Now, towards the end of the book, or I guess actually in the abiotic discussion, when I begin discussing Thomas Gold. Now, Thomas Gold was a very brilliant physicist, very, well versed in chemistry. He basically escaped Europe in World War II and got to London, and he actually helped develop radar. He had a lot of remarkable. He was a very not conventional thinker, and Gold, I think, basically, he ended up at Cornell, and he produced a book called The Deep Hot Biosphere. See, he was the first to catch on to, or one of the first to catch on to, that in the bottom of the oceans, there is this biosphere that is fed through these thermal chimneys, which exude from the mantle of the earth various hydrocarbon products, usually gaseous, but in terms of, and various like methane, etc. But a lot of complex hydrocarbons come up through these thermal vents, and they feed the basically bacteriological structures that exist deep in the ocean where there's no light. So they're not being fed by photosynthesis. They're being fed by the ability to process carbon, carbon and hydrogen, basically hydrocarbons. They live on hydrocarbons. Now, when Thomas Gold found those, he realized that the mantle of the earth was producing hydrocarbons, and that it was coming up through the earth into, where it could get out of the crust. And these vents were one place it could get out. It could also get out in fractures in the bedrock, the basement bedrock. And I even looked at Saudi Arabia. I got the tectonic structure of the bedrock under the Saudi oil fields, and it's deeply fractured. Yeah. Another reason, like in the Gulf of Mexico, where this Chuluksa asteroid hit at the end of 65 million years ago. It's when the dinosaurs were extinct, became extinct. It deeply fractured the bed of the Gulf. So the Gulf of Mexico is another place where we find a lot of oil, because it has a way to get to the surface. In fact, oil will bubble up out of the ground if you don't, withdraw it. I mean, Beverly Hillbillies, which everybody watched in the 50s, starts with these people get a farm in Oklahoma and the oil's bubbling out of the ground. Well, that happens. They used to jar it up and think it was worthless. Or, the properties of oil to produce energy were discovered.
Is it true that they're finding oil right now at depths that can't be explained by organic origin or not?
I go through that. I look at the offshore
Right.
drilling and the deep earth, hydrocarbons, and show how off the coast of Brazil and other places, they're getting oil 10,000 meters down. I mean, first of all, the great advantage of offshore drilling is you get down several hundred or thousands of meters before you have to drill through any earth. So you're getting piped down through the water, and then you start drilling at the bottom of wherever the sea bottom is. And then you drill down into that to find where oil is found. Now, at these levels, there's no biological material, although sometimes they still try to argue that there's, layers in there which include residue of biological material, but it's fairly far-fetched. I think most petrogeologists in the field don't worry about where the oil came from. They just want to go get it. And so therefore they have become accustomed to offshore drilling. And we're drilling offshore because that's where our technology permits us to drill. But you can drill for oil in the North Sea, which they're doing extensively, and that's not on the coastal plain, which is shallower. I'm confident that you could drill throughout the ocean bottom if we had technology that could reach these depths. Remember, light doesn't reach some of these depths. So you're dealing with the ocean bottoms at very, very deep levels. But I'm confident that we would find oil if we could drill there, especially if we traced where the fractures in the bedrock were, or where these thermal hydro chimneys were. By the way, the Woods Hole Oceanographic Group went and studied this one of the hydrothermal plains and determined, wrote an article in Science that said this was hydrocarbons produced by the Fischer-Tropsch process. One of the first articles I've found where there's confirmation that there is inner earth hydrocarbons formed by the Fischer-Tropsch process. So that's there, that's on the record. Now that's ignored still today by the conventional thinking of oil and natural gas. Another part of the book I think is very important is when I discussed earlier in the book the peak oil theory, which was one of a guy named Hubbard, and he was a shell oil chemist in the 50s who said, was only so many dinosaurs, only so much prehistoric biological material. There could only be so much oil and we were going to run out of it. And he drew a napkin, but basically a normal curve, which is, a bell-shaped curve. And he basically said, as we use up the oil, we'll reach a peak, and then we'll have diminishing oil until it's exhausted. Well, again, all the predictions on peak oil, and they had a whole, even as late as the 70s and 80s, the peak oil guys were still around. They used to demonize me constantly. And I still have clipped some of their tirades against me because I think they're pretty silly. At any rate, peak oil guys are all gone, especially after Donald Trump showed that the United States didn't run out of oil, that we are are able to produce enough oil today to be a world leader in oil production and exporting. And the shutting down of the producing of oil, which is going on in the Biden administration, is strictly a ideological move. Because I think another one of the people I've studied extensively, Julian Simon, who was I think, very brilliant natural resources kind of economist, population economist, looking at population as resources. And he is now passed away. He was at, I believe, also at Columbia. And he argued that, the running out of hydrocarbon fuels has been going on. It's kind of a built-in fear. Even in the 1850s, the British were worried they were going to run out of coal. Well, we still have more coal than we know what to do with. And Simon's point of view was that these resources are so extensive, they're not infinite, but they're also not finite. In other words, they're so extensive that we'll probably never run out of them. Our technology permits us to get cheaply coal or oil where we before couldn't get it economically. Technology permits us to process it and develop it from shale, for instance, shale oil. Technology wasn't existing before. Again, shale is another form of I would argue, metamorphized oil. And shale can produce oil through various chemical processes, just like the Fischer-Tropsch process. The truth is, you can produce oil through all kinds of even fermentation processes. It's simply the ability to get a chemical reaction to occur between something that has carbon in it and something that has hydrogen in it, where they form hydrocarbon chains. It's not limited to one way to being produced.
So is there any truth to this idea that you could exhaust an oil field and wait 50 years and go back again and oil returns to it?
There is. Again, I think Saudi Arabia is probably the best case. I used to debate, when he was alive, Matthew Simmons, who wrote a book called Twilight in the Desert, and he built a career telling Saudi Arabia. I believe he was in Houston in Texas, and he was really more of an investment banker in oil production. And he would tell the Saudis they're constantly running out of oil. And the Saudis even today will tell you they don't know how much they've got. Because again, if it's coming up through, these are very deep fractures under Saudi Arabia. So they've got a constant flow of oil into these fields. Now, you can take a field and deplete it. And waiting for it to come back may not be, not going to happen overnight, because again, human beings think in terms of time is measured by our lives. Right. And our lives are fairly limited, 100 years. Well, in geological time, that's seconds. And these processes in geological time in human time, they're very slow. But again, that's just because of our perception of time. And the Earth doesn't run itself according to a schedule that's conducive to human beings. We're just the latest species walking around on the planet. There have been 5 massive extinctions of all life on the planet before we got here. And so therefore, this planet is not designed to suit our needs. It's any more than it was designed to suit the needs of the dinosaurs. The dinosaurs existed because the planet was adaptive to creatures of that size at that time. Today, we don't have creatures walking around of that size, which again is another thing I explore in the book, which is the expanding Earth theory. The Earth has not remained constant. And a larger Earth, which would have more mass, would have more gravity. We watch space moon shots. Neil Armstrong bops around like a bunny rabbit on the moon because of the lesser gravitational field of the smaller body, smaller mass. Whereas if the Earth expanded, the expanding Earth theory would say dinosaurs were just too structurally big. These long necks, these big structures just didn't function in a larger environmental, in a greater gravitational field. which would be produced by more mass than the Earth. But again, people think of the Earth in uniformitarianism type terms. They don't want to think that it's got drastic changes.
Right.
That the Earth has gone through massive, drastic changes in the 4.6 billion or however many years scientists say the Earth has been around.
Yeah. So, is it the mainstream consensus right now that every hydrocarbon came from life at some point? And if so, how do they explain? Aren't there supposed to be hydrocarbons on Saturn and other planets? What's the explanation?
There's hydrocarbons all through our solar system. Titan, which is one of the moons of Saturn, is predominantly methane. And its whole atmosphere is methane. You'll find hydrocarbons commonly in the solar system. And if you look beyond it, you'll find them as well. I mean, a lot of what forms Earth, even quasars and stellar material shapes Earth. There's not a stable place, and we're not isolated as a little, protected environment. We're subject to massive forces that go on, and if the chemical processes exist on Earth that can form hydrocarbon fuels, where you've got the necessary chemicals, the necessary atomic structures, and the necessary conditions of temperature and heat, etc., you're going to find hydrocarbons. They may be gaseous, they may not be. But again, as you're taught in Chemistry 101, a liquid and a gas and a solid may all have the same atomic structure, just different forms of the molecule in their different temperature and pressure conditions. So water boiling is still steam, is still the same chemical composition as the water.
People must push back against you and say you're not correct about the abiotic hydrocarbons. But do they say that then every single hydrocarbon on Earth came from life? Or do they admit, oh, maybe some of it didn't, but most of it did come from life? Or what is their position?
That's the most recent iteration. I think the Woods Hole oceanographic exploration of these deep Earth hydrotherms and publishing it in Science, and it's a very, very good paper, and the science is quite meticulously done, so it's hard to refute it. Once that was established, Thomas Gould's work on the deep hot biosphere, I think, makes it impossible for any honest petrochemist to say that all hydrocarbons are biological. But they don't like to be pushed that way. I mean, I have a couple of quotes from the textbooks which say that, still they argue it's predominantly, or that they're just very reluctant to give up on any idea. They say it's microbes. First it was dinosaurs, then it got down to plankton. Now they're down to bacteria and microbes. They're just desperate to continue to find a biological link. Because you see, if oil is a natural process of the Earth, and it can be produced naturally, can be produced synthetically, and we're not running out of it, these petrogeologists seem to think they are less important because we don't need them to find it. You can find oil studied where fissures and bedrock fractures are. If you study, that's probably one of the best ways to find the likelihood of prospecting for oil. But again, there's a lot of misunderstanding about Earth structures in general. Until the fact that this asteroid hit Gulf of Mexico was not immediately accepted. I write about that in the book, how long it took for the scientists to put that together, and to prove that Earth had been hit by a massive asteroid, and the Earth has been hit multiple times by asteroids. And so again, those who want to think outside the box, who are thinking about that the asteroid that hit 65 million years ago may have been preceded by others or followed by others, and may yet be followed by others. NASA is still out there constantly searching for asteroids that are going to hit us, and they're trying to figure out ways to blow them up or whatever before they get here. Well, that's unlikely to be successful right now with our current technology, but it does indicate that NASA, without admitting it to people, understand that this is
Yeah.
not a stable place. We could
Mhm.
tomorrow get hit by an asteroid or a series of asteroids that would dramatically change the entire chemical structure of Earth and its potential for life.
So, do you have any sense for how fast the new oil is being formed, or do you think we could burn oil at the current pace for hundreds of years using either new oil or making our own new oil, or what do you think?
Hundreds of years. I mean,
Yeah.
there's no limit to it. I mean, the amount of shale oil in the United States is huge. And it's that way around the world. I mean, Great Britain still has an enormous amount of coal. We have an enormous amount of coal. And at deep levels, we have coal that, are not that hard to find. We have to shut down West Virginia in order to make sure we don't produce coal, because among the global warmers, that's the process. First, they were worried we're going to run out of it, and that was one of the major fears about using hydrocarbon fuels in the 50s, 60s, and 70s. And then as this theory developed, that I trace it from people like Harrison Brown at the end of World War II, worried about overpopulation. Paul Ehrlich, too many people, we're going to exhaust the resources of Earth, which is another fairly silly idea. I mean, we somehow or other think we're that significant on Earth.
Right.
Human beings are simply not that significant in terms of what the Earth is capable of supporting. Now, the idea that we can support billions and billions of people is there, but it would take advanced technology, would take the ability to produce the food, to have the energy. But if we allow ourselves to use the resources of Earth, it's one of Julian Simon's main propositions. There's no reason we should want to limit population. We'd want to have the gene pool. We'd want to have, you would have to argue in a Holocaust how many geniuses were killed, how many Mozarts,
Right.
how many Beethovens, how many great writers or great whatever were killed. You want population in order to produce the potential for having enough people around who are capable of brilliant work. And if you reduce the number of people, you're reducing the probability those people will surface, because they could be not born or born and killed.
Yeah.
The idea of the second idea that, the major idea I'm combating in the book, which I'm fighting against many of these ideas.
Okay.
But again, the idea that carbon dioxide is somehow a poisonous gas is another completely. I mean, if burning hydrocarbon fuels exuded carbon monoxide, they might have an argument.
Right.
Because carbon monoxide is lethal in intense doses. People commit suicide by turning on their cars in a closed garage, or putting their heads in an oven, breathing the hydrocarbon fuels. But the point is, if you take a look at carbon dioxide, in terms of historically, the Earth has less carbon dioxide on it today than it has had geological time, going back hundreds of millions of years ago, back to when the Earth was first formed, when the Earth apparently was very much molten, a lot of sulfur, a lot of more igneous activity, volcanoes. There was a high percentage of carbon dioxide in the atmosphere. It's gone down from thousands of particles per million of carbon dioxide to today, where we have 400 parts per million approximately of carbon dioxide in the atmosphere. It's doubled since the Industrial Revolution, when there were 200 parts per million, but that's still it's such a small molecule, carbon dioxide, that its impact as a global warming agent is almost too small to quantify compared to, for instance, water vapor, which is about 70 or more percent of the active ingredients in global warming. And the idea that global warming is bad is also another ideologically driven idea, because, for instance, we're now in an interglacial period of time. It's very hard to support life in the planet in a glacial period of time. And glaciers occur every 100,000 years or so, largely because of the elliptical egg-shaped pattern of the way the Earth goes around the sun. And at its most elliptical, when we're the farthest from the sun at the extreme, we're the coldest, that's when ice ages tend to form. So if we're in an interglacial warming period, and we have this small amount of carbon dioxide in the atmosphere, it's actually plant food. And we have as your background here, we've got a greener Earth had in many ages. And as they study things, of course, you'll find that occasionally, I mean, they'll find that, there was time when Greenland, of course, Greenland today is not green, today's icebound, but they're finding that the Vikings came to Greenland because at one time it was green and fertile and very habitable. And similarly, the idea that the Earth has maintained its current size, composition of continents, all these have changed. And so too has dramatically changed there are times when the Earth has been virtually covered entirely by ice. There are times when the Earth, in the interglacial periods, are times when Earth prospers, when life prospers on Earth. So we ought to treasure this period of time. The equations that they try to develop to show how carbon dioxide is going to heat up the Earth, we're all going to die, are largely rigged by false data. I showed that with a whole chapter on Michael Mann and how their data was rigged, and they knew it was rigged. We found that out from the various emails that were linked out of this East Anglia computer in London. Were conversing with one another and admitting that they were rigging the data. Even in this interglacial period of time, we've had a medieval warming period. We've had a little ice age, which occurred right up until the time Napoleon's troops froze coming out of Russia, or Washington across the Delaware, there was huge ice flows, which you see in all the pictures. The Delaware doesn't freeze like that anymore. That occurred in the middle of a warming period, because another variable here is that the sun sometimes burns hotter and sometimes burns cooler. When the sun is in a dormant period of time, like it has been, we get less heat, less energy, less irradiance on Earth. And so Earth becomes cooler, and that can occur even in a interglacial period of time. In other words, the orbit may not be so elliptical, but the sun is dormant. Try to point out to people that climate is such a complex set of variables, of which the major factors are really the oceans and the ocean currents. That's a major factor in how the Earth's climate is, and it's variable. It looks like we're having a Arctic vortex and a La Nina current, which could produce a moderate winter, but it looks like this one is going to be actually producing, because of the structure of the La Nina, it looks like it's going to be a cold winter. And we've already in January and February could have some very, very tough Arctic periods of time and snow. These factors are far more important determining our climate than a little bit more, a few more parts per million of carbon dioxide is not going to make any difference.
So do you have any thoughts at all, any ideas on where Earth's climate is going in the next 50 or 100 years, or do you think nobody knows?
Impossible to tell. I mean, it's going to change, because everything on Earth has always changed. The variables are, does the sun continue to burn like it's been burning? Does our orbital pattern around the sun alter? Does the Earth's axis alter? That's another very important factor that determines our seasons. Do we get hit by an asteroid? Is there an increase in volcanic activity? You've got the Ring of Fire all around the Pacific Ocean, and we've had some major eruptions of volcanoes that have occurred recently in the Pacific. That started, we can have 1,000 years of volcanic activity occur, and there's no explanation for why, except if the Earth is continuing to grow and the Earth remains molten in the center, does seem to have a still very active inner Earth, which will produce probably growth. At some point, I would suspect the Earth will stop growing. Like all things, it will get old and will start shrinking, and that will change the climate too.
Okay, I'm curious, how different do you think the Earth's diameter was when the brontosauruses were walking around compared to now?
Cover that in a chapter. There's a whole, the expanding Earth theory, which again is not very well known because it's not typically studied. There's a very good Carey, who was a geologist from Australia, did a lot of work on it. And he was basically saying enough to, and I don't require his exact calculations, but he was saying that if you take a look at the gravitational field of the Earth today and the structures that we produce, and if we have structures that are proportionally larger, like dinosaurs, an order of magnitude larger, then the Earth's gravity had to be that proportionately less to support that kind of a structure. There's a principle in mathematics that, again, most people are not aware of, which is a difference in size is a difference in phenomenon. In other words, when you take a bumblebee and you make it 10 times or 100 times that size, it's not just a bigger bumblebee. The thing can't fly because it can fly only with the wings in proportion to the body that it had at its original size. Make it bigger, it doesn't work. You know, Howard Hughes built the Spruce Goose with all these, you know, the big propeller plane to get it to lift. Didn't work because it's not just a bigger plane. It takes the aerodynamics, the plane that size, to be fundamentally different until we had jets and the aerodynamic structuring of today's modern jets. We didn't have a vehicle that could fly that way. Supersonic jets, again, they're a different phenomenon. It's not just a faster airplane. It's a fundamentally re-engineered process. And so that if dinosaurs were around and they were bigger, it's not just that they, you know, the Earth, that they were bigger creatures, the Earth was the same. Something had to fundamentally change because that's a different phenomenon. Difference in size is always a difference in phenomenon.
I think I may have heard a story about back in the dinosaur days, there was a dragonfly-like bug that had wings that were 6 feet and a 6-foot wingspan. Is that possible? And would that be explained by a different sized Earth?
But see, again,
No.
Even when the dinosaurs were around, there have been structures, you know, they say cockroaches and other, you know, there have been bacterial structure, a different, the difference in size is a creature who's walking around on the surface of the Earth or swimming in the sea. That's a different phenomenon. But you can find, you know, rats may be a good example. Rats may have been a little bigger in time of the dinosaur, but basically some of these creatures have been with us for a long time. And they're now really discovering that there's great links between dinosaurs and birds and their structure. You know, even dinosaurs with feathers, which when I was growing up was unimaginable. Again, it's the complexity of these phenomenons are such that the mathematics become chaotic because little variables make big changes. And so therefore, models predicting where it's going are simply the scientists projecting their biases into where they want the model to turn out. And they make the mathematics work that way. If you do it truly, the mathematics of the climate are not linear mathematics. Linear mathematics, you've got, you know, an equation and it produces set answers. In a nonlinear equation, it may produce different answers given different values for the variables. And so therefore, you have interactions among the variables in a nonlinear equation, which often make its outcome not strictly predictable. Nonlinear equations drive a lot of physical phenomena, which again, we don't like to think about because we'd like to think we could figure everything out and everything is going to be a matter of determinate factors. But when you get a extremely complex system, and one I'll probably visit my third book, which is going to be on my third book will be a lot more about relativity theory. But let's just take, for instance, human being may make 35,000 decisions a day. That's a human being. We've got, what, 7 billion people in the world? 7 billion times 35,000 is a lot of decisions being made every day. And if every decisions are interactive, such that one decision will affect other decisions, you've got such a complex model that it may be it has a feel of being determinate, but it is indeterminate because you can't predict which of the decisions are going to affect which of the other
Right.
decisions. So it's not a determinate model. You can't predict where it's going. That's where this fundamental question of, which was debated by the medieval philosophers, as to whether, it was a determinate world or an indeterminate world, whether God knew everything that was going to happen because he created the world and it was according, well, God appears to have created a world in which the mathematics function in an indeterminate fashion. Conceivably, even God, with all the ability to know all these different variables, has left it up to chance as to where it's going to go next, because that's the nature of the mathematics. So you ask me, where's the climate going to be? Where's the climate going to be tomorrow? Well, the best bet is where it is today is where it's going to be tomorrow. Okay, but again, that changes too because we have seasons. So today it's sunny in New Jersey. Well, they're saying tomorrow it's going to be rain. You can see the weather patterns forming. But again, that's just because those particular weather patterns formed today, given all these complex factors that influence the climate of the Earth, water vapor, the currents, the exact way that the Earth radiance is hitting us now, cosmic rays as they hit the Earth, which affect cloud formation. All these are variables, and they affect climate.
Very good. I've asked that question a lot. Where is this going next? And that was one of my favorite answers. But what else would you like to cover before we wrap up this one?
The book starts out with a lot of the ideology, and it's very important, the first third of the book, in understanding how the fundamental climate change model evolved, especially with John Ehrlich, to being a Malthusian, too many people. And so there's a bias here that they want to get rid of people. And the idea of using pure hydrocarbon fuels means that an advanced industrial society cannot support the number of people we have today. And they know that moving from hydrocarbon fuels will cause people to die. And in fact, that's part of the ideology, which is not going to be explained, as to hydrocarbon fuels have become the engine of capitalism and the engine of modern industrial society. And if we can't use hydrocarbon fuels, we're not going to be able to produce the types of machines and operations we have today. People will die. And that's part of the ideology that is one of the hidden agendas of the global warming movement. But as I trace the writings and I quote the writings extensively, you'll see it evolve and develop. So by the time it gets to AOC, it's part of the critical theory that we not only have to not use hydrocarbon fuels, but we've got to end racism in order to save the planet. And they try to make that into a ecological argument. The point is, the bias here, and these people who are global warming and climate change know that if they can get rid of hydrocarbon fuels, they can end capitalism, and they can achieve their depopulation goals, deindustrialization goals. And so therefore, it is really at its core, a suicidal idea, except for, of course, the elite who think that they will be the ones controlling things, and it'll be the globalists and the machines left. You'll have Klaus Schwab and his machines, and he'll run everything according to his likes. But again, these are not the way the Earth works. It's not a stable place. It's not a predictable place. And it's a place in which, the original mandate of God was go forward and prosper. And we have plenty here to prosper. Well, we're in an interglacial warming period. We ought to prosper. Because when it gets colder here and we have another glacial period of time, it's not going to matter what we do. The populations of the world will probably be reduced. Because you just can't, depending upon the extent of the glacial period that's coming next, the Earth will just simply not support the number of people that we have. So we better take advantage of it while it's here.
Excellent. I totally agree with that. As I mentioned before we started recording, I'm on Twitter a lot, and you find people a lot straight up saying that this battle is against capitalism. What we need to do is end capitalism. That'll fix the climate. The goal is to get rid of capitalism, it seems, for quite a few people.
And to get rid of people.
And to get rid of people. Yeah. Interesting. Okay. Anything else we should cover?
No, I think that's it. I mean, the book, I think, is not necessarily an easy read, but I try to explain things so they're, it covers the mathematics, it covers the chemistry, covers the physics and the political philosophy behind this. And I think from the reviews it's gotten, I'm pleased that I achieved my goals with the book. It seems to be even top scientists have liked the book, even though my training is as a political scientist. I'm not academically trained in chemistry or physics or these other mathematics, but they got approval from those who are academically trained in it. And I was very pleased to see that. And as I say, it's the first book of 3. These 3 are going to, when I complete them, second book will be published next year on neo-Marxism and cultural Maoism and anarchy. And that'll be about the critical race theory and how it developed, critical theory in general. I think that'll be another major intellectual statement that I'm making in my life. And then the third book, if I get a chance to finish it, will be the completion of these thoughts. But I'm beginning with climate change because I think it's obvious that the climate science is patently wrong, if not silly, behind global warming and the whole idea of climate change induced by carbon dioxide. I think it's a completely concocted idea, and any legitimate scientist is not going to be particularly persuaded by it.
Excellent. And just one last side question here. I bought a copy of your book on Kindle, and I probably will buy it on Audible too, so I can listen to it while I drive. But do you have any observations on how people are consuming your work nowadays versus hard copy, Audible, or Kindle?
Well, we published only 2,600 hard
Yeah.
copies because,
Okay.
again, it was expensive. The book was about $30. Now, at the moment, Amazon's publishing the books in paperback. It looks about identical to the hardcover. I don't see any difference, except the cover is soft. I mean, it's extremely readable. I still like a book. I'd like a book to be able to read it and then pore over it and go back and forth. And many people I don't annotate books. I never make notes in books. People do. And I still think there's a value to the printed word.
Yes.
But the audio and the version on Kindle or the ebook are very popular with this book. And I think this book will have a long life because it's not a book that is written to apply only to current events. It's more deeply into the science, which I think will be an enduring question. I think the book right now will be demonized and not appreciated. We have a hard time getting it read, but even by the time I'm dead, it may be more read than it is today. Because I think there'll come a time when this current disinformation, this current massive lies that we're immersed into will get recognized as such. And I think we'll come out of this. At least I hope we do, because the alternative will be to have a nuclear war and won't make any difference.
On that note, let's go ahead and wrap up. But thank you a lot for taking the time. This is a very good conversation, and I'm excited to get it published.
Well, thank you for all the work you put into doing it and all the work you're putting into this effort to get exposed the truth. And my books are about the truth. Every one of these books can be called The Truth about neo-Marxism, etc., the truth about energy, global warming, climate change. And I'm aspiring here to really get to the truth, whether people like it or not. This is what the science will justify. It's what the writings of the political philosophy show. And I'll stand by everything in the book and be happy to debate or refute anybody who says otherwise.
That sounds great. All right. Thank you very much. Talk to you later.
Thank you.